All right, welcome. So, yes, last time we were working on tying up the knots with the heap memory addition and got the bindings. Started working on the bindings, and I did some work off stream and actually made it to work now. So basically, string interpolations now work. Basically, so actually, one thing that I wanted to try was because I wanted to try like if they still work like you know, across threads. So how you could test this is by having, well, let me just show that this works first. There we go. We get 3 different hello worlds. I guess we could do like this to show that it's like 3 different things. Okay, and then so basically how it works is that this is bound to this thing. This will be stored in the read-only memory area. So this will point, basically a pointer to the read-only memory area. And then this string is like a pointer to the heap. So we allocate 2 elements here, one for this and one for this. So the first element is basically well, it's going to be whatever result is going to be in here. So in the end, it's just going to be the pointer to the read-only read-only memory, and this is also going to be a pointer to the read-only memory. So this is kind of this, you know, 2 pointers to the read-only memory there, and then the entire result is stored on the heap. So this string is stored on the heap, and then the echo will and both the read-only memory and the heap are shared between threads. So it should be thread safe, so to speak. And this echo will take this pointer to the heap, and it will turn this into an actual string in Zig by looking at all the elements and turning them into strings as well. So it's kind of like a recursive thing going on there, because this, as we display here, you can actually have any kind of, you know, any kind of expression in here. You can even have a string, and even have like, you know, this could even be multiple interpolations, like nested interpolations like this, unless it doesn't work, but it does work. Okay. That's good. Because otherwise it would just be like, if it's just one, it's just a pointer to read only. This actually changed from a pointer to read only to a pointer to the heap now, but it still works. So yeah, so the materialize string action, as we call it, is turning this thing that we get into a string when we actually need to call echo. Okay, otherwise it's just stored as kind of like a slice on the heap with a bunch of, you know, different kinds of values that can be turned into strings, basically. And you can have non-strings turned into strings, like X codes or numbers as well. But what I want to test now is basically doing this. So hello world. So that is now there. So X points to the heap, and then we want to have a block that echoes from block, and hopefully that works. Okay, it doesn't work. Interesting. I didn't get any message though. Curious. So we do get the output, and then at the end we don't actually get anything. Maybe get slice. This looks like an infinite loop here, like a infinite recursive thing going on, where we have maybe a slice that points to itself, perhaps. Okay. So it's like when we try to execute this last block here. Right. Okay, well, let's do this. Let's do that, and then we have to have the interpolation here to store this on the heap. That's what I want to test. Actually, you know what? Let's try this first, just so that we test that this basic thing works. Okay, so that works, but this does not work. I think it's like goes into an infinite loop there. So let's go to the debugger and see what we can see. So here's the string being compiled. So we allocate a bunch of stuff. We have 2 elements, and we set R to be the address, yes, and then R+1 is the read-only there. Yeah, and we set it again just as a precaution. This could be optimized away, but whatever. And then R+2 is also a read-only here. 7 to 6, 0 to 7 makes sense. Okay, then it's popped. Yes, and stored on the heap. And now we're doing the block here, so we are creating the block pipe. That looks correct. Okay. Set a bunch of options, forward, and fork the block. So now we're in the block here, and the block itself has fork on the output pipe of the block, and the main thread is waiting for the block to finish. Now we are also storing, right, so we're storing the stream thread on the stack, and we're forking now the execution of echo here. Okay, so here's the execution of echo, I think. We create a string first, and then this one will wait for the execution thread. Okay, so we create a new string, which is this inner string here, with I guess 1, 2, 3 elements. Looks correct. So we're setting that there. We're setting our right. So here's the first element. It's 11 plus 0. Did I create like a read-only thing? No. So I can't really look at the read-only data, but yeah, it should be. Well, it's plus 0 anyway, so it's like a 0 length string, so that's fine. And then now we have a segment, right? Yes, because this returns something there, maybe. Right, we're creating a segment. We'll set it to R. Interesting. Okay, so here, I think here is the... We actually can see now the circle dependency happening here, because we're setting this to R, which means that... But R now points to the address of this entire string. And we're setting... Ultimately, we're gonna set one of the elements to the address itself. So that becomes a circular dependency. That is weird. Why is it doing that? And then, of course, we get the from block string over here. That gets popped. We push our... Right, so that's the argument, the string argument. Now we're pushing the echo string and the argument length, and then we execute that. And now this should go into a circle dependency. So what is happening is that when we compile the string, oops, so here we're looking at like what is the result of this compilation. Does it use the R register? But it didn't look like it actually was... It didn't look like it was compiled at all. Because it was an identifier. Well, it was compiled, but it didn't produce any instructions. Because it was an identifier that we looked up and that we found, and then we just returned the result of the binding, which apparently resulted in the R register, which shouldn't happen actually. We shouldn't store the R register as a thing that like a variable could be bound to. That should not happen, because that can lead to all sorts of weird stuff, especially like, yeah, the thing that we saw here, where it's like, yeah, okay, so your R, well then we store that, but the R is now, it's volatile, so you can't really store it like that. When we store it, we have to... So basically, if we go back here, so it means that X was actually R, which is not good. It should be like almost like dereferenced or something. Whoops. Compile binding. So we get the result. Now the result is like R, so that's also like, maybe we check here. We could add a check here to see, well, if result is R, we actually need to kind of... We don't really want it to be R, that's the thing. Like, should compile expression ever result in R? I mean, I guess it could. Then we have to kind of take care of that issue here. In that case, we kind of have to turn this result into something that is storable. I guess, well, non-volatile, I guess, is the correct term. Yeah. I'll just BRB 1 second here. All right. Yeah, so how do we do that? I mean, it would be cool if we could just say like non-volatile. But I need some kind of plan to know how to do it. I think we can't really if we like, I don't think we can really store it on the stack, maybe because that's not thread safe, or I don't know, thread safe is the correct term to use, but it's not like you can't pass it into, you can't use it in another thread because it's thread local. So to turn it into a non-volatile would mean maybe putting it on the heap. Yo Penguin, welcome back. What's up? How's the sports going? Yo Zen OX7F, what's up? Yeah, zigging it up. Have you any zig? Have you looked at it? Looks like a beauty language. Yes, I really like zig. I agree. It's a really nice language to look at. Most of the time. Sometimes it you can easily get nested stuff, as you can see here. It's like you probably always start off with a nested because everything is like in a struct. And then, although you could use the top file as a struct, but I don't really like that pattern. I don't know. But then, yeah. So maybe I should use like 2 indent. I don't know. I don't know why I'm using 4. It's just I'm used to it. So, but then you have like, you know, you can do switches. Then you get like 2 more indents. Yeah. There's a lot of indentation, but I really like, you know, these what you call this, like implicit field access is really nice. Expression facilities. I'm not sure what you refer to there. Let's see, result. I might have said something that I forgot. Sorry about that. But yeah, it's I really like this. I really like this. Like the implicit field access is so nice. I'm not sure if other languages has this. Like, I can't think of a language that has this. Like, I don't know if C or C++. No, I don't think so. I actually don't know, but yeah, that is a really nice thing. Yeah, so what this is doing, this is basically invoking a function that is defined on a struct, but it's not a method. It's not a member method. It's like a static method, or yeah, it's a static method, you could say, because it doesn't require an instance. Well, it doesn't accept an instance. Although you could technically also call member functions like this. You can, and then supply a member function. But then you could also just say member or self dot instead. But technically you can call, like, instead of saying self scopes declare here, I could remove that. Although if I do, then I have to provide the type because we don't know which one it is. But anyway, here I could actually do compile expression and then self instead. So there's like, you can do this if you want. It's like, this is just syntactic sugar. Why zig? Well, okay, well, it's not that deep really, or my answer, I guess. It's more like, well, I've tried a bunch of different languages throughout the years, and Zig is like one of the languages, I guess, that really fit the bill for me, like right now. Like when I started with Zig, I actually wanted to, I wanted to get into game development, and so I wanted to have a language that I could have like total control over everything, basically. And so Zig was like a perfect match because it's like a low-level manual memory management language, and it's simple. It has it feels new as well, and it has, like, you know, the comp time stuff is very interesting. It has a bunch of stuff that is like, feels like a breath of fresh air compared to many other existing languages. That just feels like rehashing the same concepts except a little bit different, you know, a little bit different syntax here and there and some features here and there. But Zig actually, it feels like a really nice new thing, and yeah, it has just been a joy using it. So yeah, that's basically it. And I knew I didn't want to use, you know, C++ or C because of, well, I've already used C++ a bunch. When I started out, I started with C++, but it just feels, I don't know, archaic and fragile when you use it. I don't know. There's something about it that just, okay, I just remember the feeling of going back to C++, and it was like not enjoyable at all. So I don't know. I feel like with Zig, I feel more safe. I can't explain it. But it's like, I don't know. With Zig, I feel like now I can basically, whatever I need to do, I can do it in some kind of way. With C++, I feel like I can't really. It's like I have a hard time figuring out how to do things. Yeah. So it's like, I think maybe C++ is like too far off its own way from other languages that I've gotten used to. Other patterns, I'm not sure, but and also it feels like when you start to use the standard library, it's hard to kind of understand what is actually happening, I think. I know it's like, it's functional. Some of the things are very functional programming, which I do like, but I don't know, for some reason C++ is just not speaking to me. I mean, you're not safe. Well, I'm not sure if you're more safe in Zig than C++, but you know, you can still get like, you know, bad pointers and seg faults and have to deal with that. But as long as you're kind of, you know, I mean, I guess the same is for C++. As long as you're doing it in a certain way, as long as you keep to certain standards or a certain process, you will reduce the amount of those kinds of errors that you get. But of course, things can still happen. But yeah, I think that Zig, I don't know. It's just a feeling that I get when I try to when I went back to C++ one time. I just didn't enjoy it. So, but yeah. I feel like in Zig I have more. I have a more understanding of what's going on right now. At least maybe that's just recency bias. But yeah, because with C++, I never got into those kind of different kind of pointers, you know, smart pointers, those kinds of things. I don't think those even existed when I started with C++. So I never actually learned what they do, but I have a vague idea. It's something to do with like moving ownership and keeping track of when to actually deallocate something. So, but it's like, I don't know, it just feels like a bunch of unnecessary, or maybe it's not unnecessary, but I don't know, I don't want to learn that stuff. I just want to do it the Zig way right now, which is basically just to use like allocators, manually craning and freeing stuff up. Well, you can use different kinds of allocators though, so you can use like arena allocators to free up a bunch of stuff automatically if that pattern fits. But yeah. Are you currently an employee? Yes, I am. So I'm currently, well, my day job is a web developer, so. But I have been programming for a long time. And right now I'm trying to figure out how to deal with this. What about you? Okay, when I see Soten fan, I see Symphony of the Night. I'm not sure if that's what you're referring to, but yes. I had that when I was growing up on PlayStation. I'm not sure if that's what you mean, but yeah, it was. Oh, are you talking about Metroidvania? Because yes, I love Metroidvania. Metroidvania is like one of my favorite genres. Especially like side-scrolling. Yeah, Castlevania Symphony of the Night, yes. Yeah, everything about the game is beautiful. I guess everything except balance, but I think I saw like a development documentary or whatever, or like an interview, and they said that they were they were like putting all kinds of things in there, which which you can see in the game is like there's a lot of things that are like unique in the game. They just try to cram a bunch of stuff in there, so it's no surprise that it doesn't feel like super balanced. Some of the items are like super overpowered, but and then like some of the monsters are, but yeah, it otherwise it's like a perfect game. Why did you bring that up? I'm curious. Okay, so can we actually store it? No, we can't store it on the stack because that would modify the stack in a non-balancing way. So we can't do that unless we add like a mechanism to say that, well, we want to kind of turn this into non-volatile and then we want to consume it, and we have kind of like an interface for it. So if we put it on a stack and we consume, that means we want to pop. But then I don't know. No, I asked why you're asking me if I was a Symphony of the Night fan. That's what I was asking. I can hear the music now. The opening when you enter the castle for the first time. So something Metroidvania. Oh, I see. Vania. Oh. Well, okay. So, okay. So Metroidvania is like it's a genre where yes, it's merging Metroid with Castlevania, or that's like, I don't know, it's kind of like a weird tag because it's like, or I mean genre, because it's like, or name for a genre I should say. Like the genre itself makes sense, but the name for it maybe is like, you know, it doesn't really explain itself. And even if you know it's Castlevania and Metroid, it's more like leaning towards the Metroid. It's not like Castlevania is like, yeah, it has a bunch of different, like if you're looking at the early Castlevania games, they are very different from like Symphony of the Night, for example. But it basically, what it means is that you have some sort of progression in the game where you get like upgrades or items that let you access new areas. Hollow Knight is a good example. I do recommend Hollow Knight, and probably a whole bunch of other people as well. I played it when it came out. I didn't actually know. It just looked like, I mean, I was just looking for a Metroidvania game, and it turned out to be like one of the best. Well, I won't say anything, but I don't want to put like false hopes for you, but it's good. I will say that. I wasn't a big fan of the art style actually at the beginning, but or even now. But despite that, I still think it's like one of the best Metroidvanias. I do love the 2D kind of pixely aesthetic, but Hollow Knight doesn't have that. But Symphony of Night, for example, like that aesthetic is really nice. yeah, so Metroidvania, yeah, I mean, yeah, so some kind of progression. You get upgrades. You can access new areas. Oftentimes, you have to backtrack to, like, there's a lot of secrets. You go back. I mean, it's kind of like have you played Metroid? So it's like Metroid, because Metroid in itself is kind of already like a Metroidvania. Like Metroid has all the kind of components that a Metroidvania has. So it's really more like a Metroid game, I would say. Like, I don't know why Castlevania got part of it, but it's basically because I think it's because just Symphony of the Night was such a huge impact, and it kind of merged those concepts. But it also had like levels and experience. But I don't think that's necessary to be a Metroidvania game. Like, you don't have to have like levels and experience, or even equipment. Like, just some kind of upgrade system. Yeah, it's not an easy genre. It's not a good. I would say it's probably not a good first game project, because it's whatever you do, it's probably gonna be larger. Like, it's probably gonna take more time than you think. Because I spent like a year on building my game, and I still have like a long ways to go before I can consider it complete. And my plan for first was like to have a lot more things in it, but I think I'm just gonna cut it off at like the first boss or something. I don't know. We'll see, but it's way too much, and I would like to do other things as well. But it's like it's I don't know. I had a hard time like figuring out what I wanted to do, because it was like, I want to be passionate about the games. I don't want the game to be just this small kind of proof of concept game. I want it to be something that I like to play, like one of the genres that I like. The problem is I like those big ambition-y projects. I don't like to play small proof of concept games because it's too small. So that's the conundrum. However, I do like arcade games like Robotron 2084 or whatever it's called. That is a fun game. Like those kinds of games I do like. So maybe I'll do something like that. Or automation games. Because that you can start off and then just add more things. Probably. I don't know. A real-time Metroidvania. Can you imagine something like Castlevania but online? I don't think so. I think like, well, maybe there is some idea there, but I don't know. I think that Metroidvania is like inherently like a single-player experience. I don't think I've ever heard of any Metroidvania to be multiplayer. Although, I mean, I haven't tried every game, so... But, I mean, okay, I could think about being like multiplayer, like being like, I mean, there are, oh yeah, sorry, I forgot, like there are things like Trine, for example, or, Lost Vikings, but I don't think that's really the same thing. It's more like solving puzzles together. I don't know. I mean, I guess you could, if you have like a co-op type game, maybe, that you get like the same upgrades or something. Yeah, I was thinking more of the design of the game, like the actual implementation is a different thing. So of course you can create a multiplayer game. The question is, how is the design gonna be? I think is the more pressing matter there, because it's like, well, to me, a Metroidvania is like inherently single player, but there might be, you know, you could maybe experiment with a multiplayer. I'm not sure. There might be something out there that already does that. But it does. It sounds like it clashes a little bit with the idea of the design of the game. I also think of something like, you know, Terraria, for example, which is like you can have co-op, and but it's more like you're gathering like resources to be able to. Well, I haven't played Terraria that much, to be honest, but or Minecraft or whatever, some kind of game where you can gather resources together to kind of upgrade and be able to access more places, but also that's also like procedurally generated, whereas Metroidvanias are usually, you know, story kind of story driven, and, you know, designed worlds. Yeah, but that's an interesting. I've never thought about that. But yeah, that's gonna be even more ambitious though than, I think, a single player Metroidvania. Where's the gap between Metroidvania and Mario-like games? Only reasons items progression. Well, a Mario-like game is more. Yeah, you can get upgrades, but they are like temporary upgrades. Like you get hurt, you lose the upgrade, and you can just replay the stage. Like for one, the stages are separated into, you know, their own. You can replay a stage over and over, and you can start off with no upgrades and complete the level and do everything in the level. It's kind of like a mini Metroidvania inside one level. Whereas a Metroidvania, the whole world is, you know, at the start you only have access to a certain part of it, and then you get more and more things. I mean, to be honest, like Symphony of Night isn't really that much of a Metroidvania game, because it's not really like that. It's more like a kind of like an action, like side-scrolling RPG, because you're just progressing through the castle. It's not really I mean, you do get some upgrades, but it's not really based around that, I guess you could say. Like it's like eventually you reach a point where you can't go further, so you need some upgrade. So it's more like it's limiting some. It's like, I would say it's lightly Metroidvania, even though it's like probably the game that started the whole term. But like, yeah, Mario games is more like, yeah, you can access the upgrades in each level, and you get them like over and over again. In Metroidvania, you get like an upgrade one time, and then you always have it. And it's like Mario, yeah, you complete one level, you get to the next level. You complete that level, you get to the next level. Whereas Metroidvania is more like you explore. It's like, I think exploration is like one of the huge things as well. Like exploring, finding secrets. Although that's also true for Mario games, though. But yeah, so I guess you could. There are like a lot of parallels between Mario games and Metroidvanias. Yes, I did. I did play it. I did find the inverted castle, although I don't remember how exactly. But I do remember finding the end, like the fake end, first, and then thinking that, well, that was quick. I was actually thinking that it felt like something was missing. It really felt like this was not a satisfying end because you didn't kill Dracula. And yeah. Oh. But I don't remember how I actually found out. I must have read it or something in like some kind of magazine or something. When did it came out? '97. Okay, so I was like 10, 11, 12 years old. Something like that. Yeah. What we had was we had like magazines that would sometimes have like cheat codes and, you know, tips and tricks. And I think there was like you could call somewhere, but we never did that. And then you had, you know, neighbors who would also maybe got some other source that you could ask for. Or yeah, that would have that. Okay, I need to figure this out here. What is this? How do we solve this? I mean, we could put it on the heap, I guess. It's either that, or if we're checking like, okay, well, if the result is like the R register, we instead of taking that, we take the content. But we don't have the content, that's the thing. We have to store it somewhere. And I think we have to store it on the heap. Because we don't, otherwise we have to make this whole mechanism of being able to share or have these non-volatile results, share them between threads and all that stuff. No, so yeah, so I think what we want to do is we want to store results on heap if it's the R register, and declare a pointer to that heap place, to the heap, to the allocated heap thing. Just go to why building a bash like script language. Well, there's like basically two reasons. One reason is I don't want to learn the bash syntax, because I constantly have to look up things, and I don't want to have all those different kind of syntax in my head at all times. And then the second part is that I think it's just fun to build a language. Whoops, sorry. Yeah, there we go. Okay, so what we need to do is we need to check if you are the register R. Well, actually, we could check like is volatile. Maybe. It's such a weird thing because everything is volatile basically anyway. But I guess it depends on what you mean by it. It's volatile, whereas like, yeah, if you compile something, you might have changed the already like the result. It's like you're losing the thing within a context. Okay, well, anyway, we're checking if it's the R register. If it's the R register, we actually want to change the result. So what we do then is we say first we want to allocate one thing on the heap, and also if it's mutable, it should also be on the heap actually. Okay, we'll get to that. Yeah. So we'll store it there. It's kind of weird though that if it's like a constant, it shouldn't actually be on the heap. It's just to be able to refer to it from. Well, no, yeah, whatever. Morning Blue, what's up? Why are you building a compiler for a scripting language? Well, it's not really a compiler that compiles to native code. It compiles down to an intermediate representation that is then ran inside a virtual machine, you could say. And the reason is because of basically to be able to support streaming pipes and like executions in blocks and functions to be suspended at any point, to be able to wait for something to be completed before we continue and so on. So I made a virtual machine thing with virtual threads, and yeah, that's basically why I saw that as the solution to it. It's also fun to make an IR. It's actually a really fun experience. And I've never done before, like the IR. So we allocate one thing on the heap, and actually now R has been changed, so we actually need to push this first. So we push no, quotation. is a register R. So we push R. We allocate. And then we set R, except it's accept we set it to be dereferenced. So we set the pointer where R is, we set the content of that, so basically the allocated thing here on the heap. We set the heap location to be whatever this will be up here. So I think we need a ref here actually. Okay, so this will be result ref. Name is identifier ref, and then set ref to be R. Okay, so now we actually have the thing there, and actually now we, instead of doing that, we can dereference the ref instead and set that we set yeah. So that's the thing. We set R to result ref dereference. I'm pretty sure. Just to understand, compiler zig will be the virtual machine or engine that runs your scripting language. No, so compiler is compiling the AST into the IR language. And then I have an evaluator, it's called, that will create that kind of initializes the virtual machine and then runs through the instructions of the IR code. So compiler creates the IR code that then gets passed to the evaluator. So this step is like building up the instructions. So when I say self.set, it means I'm creating this. I'm basically coding the IR here based on the AST. So for example, here we have well, this is a binding, so this is like creating a variable name and binding it to, like this is a binding here. We're binding result ref to this expression here, and that's what I'm doing here, or that's what this case is here is like. Okay, we have an identifier that we need to bind some result into. So this is the expression that we're trying to bind to this identifier. Hey, sorry for bonding. I'm running around to see if anyone has Node.js experience. Well, I do, and probably others as well. What's the question? I mean, I'm not a super guru expert, but I do. I mean, I do have it as a job, basically. I'm just gonna refill my coffee. Be right back. Are you a zig lawyer? What? No? I'm not a lawyer, no. I'm reverse engineering a game server. One of the requirements is making an endpoint running locally. But those web pages give me cannot get error instead of pulling the actual data from the user's file. Okay. Well, I mean, okay, so you're reverse engineering a game server. Well, how are you getting the code? Is my question. There are, you know that there are C++ language lawyers. What? I didn't know that. Decompile action scripts on the client's files. Okay. But that does not necessarily, I mean, that doesn't necessarily mean you have the server code. Although I'm not sure exactly how the architecture works on the specific game that you're looking at. And also, is it like, did you download it from like, I mean, if you downloaded it from like one of those, you know, like, I don't know, Congregate or something like that, then you, because it says like account profile, like what is, do you need the account profile? Like, what is that? Is that like in the game, or is it like, you know, surrounding the game, like in one of those platforms? Correct, I'm trying to interpret what the server needs. And no, I got it from original CD from the game. The game was called Nanavor. Okay. Well, okay, so you got it from the CD game called Nanavor. An action script. Isn't that like Flash or something? Okay, so but what you're saying is that you're trying to call the local host endpoint, and then you're saying it gives you a cannot get error. So you're trying to implement that route. Okay, is that what you're saying? So I mean, something is wrong with your server then. So cannot get error. So that it's like it, yeah. What So what library are you using for the server? Like Express or Node HTTP or Express? Okay. I mean, I guess I would. It's hard for me to kind of troubleshoot you without looking at the code. But I mean, cannot get. It sounds like it finds the server, but it's like a 404. It doesn't actually provide that route properly. Sure. Go ahead. I'll try to look at it. Okay. I'm not guaranteeing I can solve it for you. So you could do it if you could give me that if I solve it. Okay? Because I don't wanna. It feels weird to get it just to look at it. Yeah, sorry about the Nightbot. Ignore that. Yeah, I got the link. Let me share this thing. There we go. All right. What the hell? What is this? Google Drive. How do I? What the hell is this? Do I have to download it or? Okay, maybe it's easier if I just. Okay, I'll try and download maybe. So we don't have scripting in Zig? What do you mean? But so it could be cause I zipped it. Oh, I see. Download. Well, it's doing something. Okay, let me just do that maybe. Why is it taking so long? Yeah, sure. Oh, it's trying to scan for viruses. Are you sending me a virus? I'll see what this is doing. I don't know why it has such trouble. Why couldn't it scan? That's weird. Okay, there we go. Okay, let me fix this here. Let's see. It's done. Why can't I open it? Yeah. I know about the zip files, but it's. I would think it was gonna be able to like. Scan it. Okay, yeah. I'm copying it right now. One second. It's going to be interesting to see what you've cooked up here. And it's done. Okay. Oh, I get all these weird Windows files. I don't know why it does that. Oh. Can I, like... No. How do I... No, determine file. Wait, what was the thing? It's not file, it's... How do you list the files? What the hell was that command? Yeah, I just want to remove all these zone identifier files. And then I want like the full name of the file. R1. No. Yeah, okay, whatever. Okay. Do you have a package? Yeah. Wait, did you include node modules in here? Well, okay, yeah, you did, except it's like one library. Okay. Whatever. But this... It was like, okay, whatever. I wanted to not have these things, but yeah. Anyway, XML, RPC. Okay. Okay, I'm not like an Express expert. I can already see you're like using a whole bunch of stuff here. And that's already like where things can happen, where you don't really have, where I don't really have an understanding on like what that actually is doing. But yeah, you're saying that we don't want to, we're trying to get, what is account, this one. So you're trying to get the XML namespace. That's not working. Is that what you're saying? Yes. So where is that stored? Like how? Actually, it was this one. User data. Okay, so but this is. It's pulled directly from the N file. How? Yeah, the namespace is like if you provide a namespace file, it's trying to get it to, I guess, verify the JSON format. And if you don't have it available, it's not gonna work. Yeah. But it's just to verify the format of the JSON. So if you know that you have the correct JSON, I guess you could just remove that probably and try just removing that. Like, where did you get these things? Like, can you try to extract these namespaces, or perhaps just make them? You could just make these namespaces and provide them. Because then it's like, okay, well, for example, I mean, one way to do it, you could do like get XSD shard. Well, I'm just taking this one up here, and then you just you have the thing here. You can inline it. These are from the action script. I suppose I could make new ones and then provide it. Or sorry, res. You can like hard code the schemas here, or the namespaces, or you can just, I mean, I don't know if I don't remember if namespace is actually required. You can just create the namespace. You can just create these namespace files yourself. Like you have the kind of basic schema here, so you can just create them and then provide them, I guess. Yeah, if the servers are, if the official servers are still up. I mean, you're saying you get it from like a CD, so. Okay, so how do you right. Yeah, but the files, the namespace files are not like a huge deal. Like okay, number one, try doing this. Where's the account profile? Try doing this. Try just removing this. Try doing that. I mean, you're not even specifying. I think like XML, like proper XML, you have like an XML version or something like this as well. So I don't think you even need. You don't even need those. I don't think. I'm gonna double check. It depends on your XML parser, I guess. Yeah, XML namespace is even optional, like in the official. So you could try to just remove those namespaces, remove the namespaces. Try that. If it still wants namespaces, you can just create those namespaces yourself. By looking up like the formatting of a namespace, and then basically just trying to match whatever you have in your XML. Yeah, and you can even generate with ChatGPT. Yeah, exactly. Very, very good. So it's like, well, I can even run. Okay, it's trying to find the XSD file. No. I'm just doing this to get like an example. This one's for super simple, like only phone number, avatar ID. But basically that's what you could do. Like these files are not that magical. Like they are only specifying how the XML looks, and you already have how the XML looks. So as long as you can provide those on this route here, you should be good. And the thing itself is probably just an XML file or XML format. Yeah, and then it's like just copy this. Although this is, well, I guess this should be fine. Did we get the thing? Okay, so it, yeah. So it added like account. There we go, account profile. So this is how that looks. And then we run that, and then like well, the thing is with the port here though, I'm not sure. SmartFox 8443. Oh wait, is it HTTPS? No? Why is nothing happening? One second. Yeah, maybe it's because I'm running in like WSL or something. Oh, hang on. Do I have this? Yeah. Okay, there we go. And then, okay, there we go. So there, yeah. So you just do that. Yeah, you can do this to add it as add XSD as like a static folder. It will just match whatever file name you're trying to get in the folder and get you that file. So this will allow you to expose all of the namespaces at once if you put them in the same like you know, in the same folder name as this, and the same file name here. I don't know about that, but thank you. Yeah, so basically, yeah, that's, you just have to go through each of these. I can send you that pretty simple thing, and then I'm not sure how would we do this, like the XSD, like this is a nice, you know. And then if you have other types of fields, I mean, either you can use ChatGPT to do this, or just fill this in manually. But yeah, you saw how easy it was to just use AI to do it. Yeah. I mean, you might have other issues after that. Like, I don't know, but this will solve that problem. You probably put this over here. And then just search. We have like all of these. Actually, I'll probably remove everything up to XSD. Well, yeah, and then just why is that not finding the other ones? I guess, okay. So this should, and then wait, there was, I think there's like, I forgot how you did like unique. There was a trick. Currently login works and parsed correctly, but I'm pretty sure this is where it was stuck since right after the login client tries to pull the user data and join a room. Okay. Yeah. Here's all those files you need to create basically. But I mean, yeah, what error do you get? Let's do one more, I guess. We'll see if we can get past that. Also, thank you for the thank you very much for the subscriptions. It game we cannot get error on the web page, but you just fix that. Ah, I see. XML RPC response. So which route would that be? It's just XML RPC. For one reason I found that response in the client and how it's parsed exactly, but how I was doing it before I actually got the login prompt to stay active. Well, that's running, so yeah, so the XML RPC is defined as a post. So you have to do like a post, and then I'm not sure what you're supposed to put in here. Let's see how the request includes srb.connect. This looks weird. So the body is getting that it's a string. If it's a okay, so it's a string version of the body. Okay. srb connect. Okay, first of all, I'm gonna say this is a weird way of doing this, but maybe... Is it because you're sending like an XML? srb connect is what I'm sending upon that connect. Okay, but I mean, I don't think I can test this. I need like some kind of data to put through here. If I want to test it, but I guess we could look at, is this where things fail, or is that what you're saying? In here? Okay, so it might be like, have you tried escaping these? Okay, that might be one thing. This bar change plan causes the XML response something like action connect instead of. Okay. But okay, what error are you getting? Okay. And you don't get anything from this this one, the SFS server, I'm assuming. So you're saying that you are sending this response and then the client responds with error connecting to game service in your kind of like client thing. Okay. But can you see somehow that this actually gets, I mean, you're logging this out, so you can see that this handler is not getting an error or something. Yeah, okay, so it's successful here. So can you try escaping these login token account ID if they contain any weird symbols that might mess with the XML? Also, is this like, how do you know that this format is correct? Did you match anything? Okay. Yes, SWF, shockwave. I'm a little bit familiar, but I haven't actually done any scripting in that in like, I don't know how long. Okay. But you had the client code for this. So you could, I mean, yeah, so you know where they are trying to parse this. So you could go there and try to kind of look at what it could be then. Okay. Yeah, sorry about the Nightbot there. Service request broker. Where did it go? Oh, look at this. Like Java here. Okay. Whoops. All right. Okay. I mean, yeah. So what I'm seeing is, one thing that I'm seeing is these don't match up. My question is, like, how did you figure out this pattern here? How did you figure out this format? Is this like XML RPC or what is this? In the parser it says that this out parses that info, which is why it's split with colons. Okay. Okay, so temper 0, trim 1, trim names. Oh, sorry, did you get... Yeah. Are you still here? 1 second. 1 second. Now, how do I untime out? God damn it. Why can't... "48 messages were deleted." Yeah. Sorry about that. Man, this Nightbot is on a rampage. Yeah, I think it like interpreted one of the things in there as a link or something. Okay, so well, the thing is, if you look here, how do you know that this name is correct? Because if you look at here, it says, like, you know, it's like all caps underscore, right? But if you look at this does not match. Have you tried matching this direct, like this perfectly here? Or did you match this? Because I think it's probably better to try to match this. Because this is the actual data. This is like, you know, the name of the field. Or declaration or whatever this is. Yeah. So this is probably, I'm guessing here, but this is probably the name of the thing. Yeah. yeah, try that. Whoops. Yeah, no problem. Thank you for the subs. If you have more issues, I can help you. Maybe. Probably. Oh man, the keyboard went offline. I'm just gonna check how much time we have. I need to eat a little bit later as well. All right. Okay, so back to this. Okay, so if it's a volatile result, we create a ref to store the result. We set that to be R, which is so we save that on the stack. Then we want to save it on the heap, so we create a space on the heap and we set that location, the heap location, to the value in the ref. Yeah. And then we can pop, which also changes R, but we don't care about that. And then the result is going to be but now is the problem. Okay, but now is the problem. We kind of move the goalpost a little bit because we store it on the heap, but we don't actually know. I mean, we have it in R, but now R is like still. Yeah, R is still. Like we don't know this pointer. Where do we like? How do we carry it around? We move the goalpost. That's what we did here. Because, yeah, we have it in the heap now, but how do we carry around the pointer value to the correct place in the heap that we can then return and use? Huh. Maybe we have to have the notion of every compilation needs to be like consumed. Maybe I don't know. Because it's like the issue is here, like what do we store as the declaration of this binding? What can we store as a value here that we can make sure is not volatile? Like we store it on the heap here. What do we put here? Unless we can put it on the stack and then kind of keep track of how many things we need to pop later. Well, okay, I guess, you know, like in a language like C, for example, all the local variables they are put on the stack basically. And then the stack frame is restored at the end of the scope. So, so we could actually store it on the stack. But then okay. Actually, I think the stack, like when we pop the frame, we automatically restore, like we automatically pop everything else as well. So we don't actually need to kind of keep track of that. We just can push whatever, and that should be fine. Whoops. Okay, so so let's do that. Let's have like a no. We're just no. I mean, I guess we could have a ref binding. Yeah, whatever. And then we don't actually need to deallocate or allocate, I mean. And we don't pop. And then result is gonna be the ref. Yes. Do we deref or do we? Yeah, I think we deref. Oops. Okay. Yeah, because we don't want to wrap it in a pointer. We want to the actual thing. Yeah. Okay. Oh, this needs to be a try. Okay. Wait, why? Is it because of this? Yeah. Okay, let's see if this works. So it should fix this. No, it doesn't. Okay. Let's see what's happening here. We'll create that. We set that. So this should be all be good. Pop. Why are we popping here? We shouldn't pop. Oh, it's an MMO. Okay, cool. Interesting. What? So is it like a what? Like a Pokemon MMO or what? Interesting that it was made like in Flash. (3D Unity? What? All right. Right. Right, and then I guess if it's mutable, we need to have it on the heap. Well, I mean, technically no, I guess. The problem is though that if it's on the heap, it's not actually stored on, like, it's not actually thread, well, it's thread local then, so if you want to pass it on to a different set, we actually need to kind of pass it along somehow. Yeah. So maybe we do need to store it on the heap. I don't know, man. All right. So we start. Where's the pop coming from, though? Where's this coming from? Because this should work here. This is no problem, right? Or no? No, because we still get a pop, right? Where is that coming from? So what we have is compile binding. This one is stored on the stack. Right, so where is the identifier ref? Okay, so here's the string literal create. Right, that is on the heap. Right, yeah. Okay, so I did it too fast here. Okay. So So now it's stored on the heap, and R is set to the result. Yeah. And now we create the identifier ref, and we set that to the same thing as R. And now we have it on the stack. So good. And fork. But now is the issue then. Well, except it's not really. Well, okay. Oh, I see. Okay, this is still an issue because this also happens in a different thread. Yeah. Because echo spawns a thread in itself. It doesn't have, like, the block doesn't really matter at this point. Okay, so it worked before because we did something like this, and that works, and it should even work like this. But as soon as and that works because it was just a read-only pointer, but now it's on the heap. And the pointer is like no longer comp time known, so it's a runtime known pointer. And then we store that on the stack, and then to be able to refer to X. But then we pass it here to another thread, which means we have to transfer. We have to transfer it somehow. It's like this thread needs like a closure. Welcome back, Penguin. So, okay, so we could pass X, like if we see that, okay, well, we're trying to pass something, we're trying to use something from a thread that is like from an outside scope, but well, I mean, I guess we could know that if we create a new scope from in here. Because, yeah, the bindings, I think we only have like one scope right now, actually. It's like scopes, yeah, this one has push bindings. Is only used, we only have one of these. So yeah. Okay, so what do we actually need to happen for that to work? Well, I mean, we could push it to the stack of that thread. Maybe, can we actually do that? We need like a stable way of talking about that pointer. I'm racking my brain trying to figure this out here. So we could sort of figure out that we're trying to reach out in an outer scope, but then is the question, how do we actually reach in there and get what we need? That's the next question. Like, for example, we're compiling this. All right. And here we're like creating a fork. But then anything inside here needs to be transferred if it's like an outside declaration. But how do we actually do that is the question. Because there's no such thing, there's no like global stack. I mean, there is the heap, but the heap is not. Is you can't. Yeah. The trouble is the pointer gets lost, basically. We can't like find it in the heap again. We have to work with the stack to share pointers to the heap or other values that we need to keep around in declarations. And that's fine as long as we're in the same thread, but once we fork to a new thread, the context, the outer context, basically just disappears. Maybe we could have like a parent thread. Okay, well, okay. maybe we can actually look at other threads stack. If we include that in the stack pointer, like the stack pointer could have a thread number or a thread ID in it, that would make it so that you can actually look at other threads memory, like other thread stacks. And then we just include that in the thing. Yeah. And of course that means that the life cycle of that has to be kept around, but that's fine as long as we're not like executing the thing in like an async thing and returning from a thread while having other threads spawned from that thread. So okay, well, that's a future problem. Okay, let's do that thing that I just said. No, how do we? No, we don't. We can't actually do that though, because the address is just a U size. There's no way of doing that unless we introduce another type of value. Yeah. Although, okay, we could maybe do this. I mean, the problem is that we need to know in the thread if we are using any kind of, like, when we compile this, we need to know if this is using any bindings from outside. or we compile. Okay, this is like a larger issue as well, because it's not only here that could happen. Like, of course, you can have bindings, you know, in this block, for example. Now it's like in the block and in this execution thread. So this is two separate threads. Like first we have the block thread, and then we have the execution thread. So X needs to be transported first to this, and then to this, if that's the case. So maybe we need like a more generic way of looking at this. We need to kind of see that, okay, well, X is used here. So how do we get it there? Man, this is, okay. What is RN? It's my language called Runic. It's a new, well, I'm kind of, it's like a toy language right now, basically. I'm working on it to replace Bash. For me, personally. And I feel like I'm solving weirdly complex issues. No, but this needs to be solved, yeah. Yeah, RN stands for Runic. Alright, see you later, Penguin. Yeah, this is not easy. At least, I mean, right now I don't see a clear way of actually making this happen here. Maybe I do need to. I need to kind of look into how other things are doing this. Although, one other way you could see it is that this becomes like a function that takes X as an argument, and we automatically supply X. And then by extension, this also requires X. The problem is, how do we, like, we have to kind of peer into the AST like before to realize that, hey, this needs X. So this needs X and this needs X. And do some kind of like static analysis on that to get that information, maybe. Like we know which X this is referring to. Like we have the scope. But then it's like threading it through here is the issue. And once you're in the deep here in the compilation down here, is like, okay, well now we encountered X. Okay, so how do we wire up all this? It's like we need a separate, now we need like a separate, maybe even context for that, like, or more abstraction regarding the instructions for this. So maybe we say that, okay, well, we encountered X. Okay, So let's check this instruction set. Did we already request X that we don't need to do anything? Did we? Then we wire it up there. So we request X from within another set. Maybe we have like a stack. So this is one stack, this is another stack. I mean, it could, yeah, it could be that. And then it gets requested. What happens then? Then we add it to the requested list. The problem there is it will change the stack counter though. Then we would have to kind of rewire all the stack counters. I guess that's not a huge issue. We could just... although it is kind of an issue actually. Because we could have a bunch of loose stack references that needs to be updated as well. Man. We could maybe have a special address for these things as well. When I see a problem, I remember boost.spirit interpolate. Okay, I'm thinking about you know, the spirits in Symphony of the Night. Or what do you mean? The spirit attack. Or the spirit magic spell. Boost spirits is a parser for programs. Okay. Never heard of it. C++. Oh, yeah, that's old. I mean, relatively speaking, I guess, but 2001 started out. It's still worked on. No. Spirit X4 is the successor and currently under development. Interesting. Okay. But I guess, what if you consider every declaration as potentially an expression? Yeah, well, I think I'm not sure if the problem is the parsing here. The problem is, well, it's not really evident from the code here, but basically, okay, let's simplify this a little bit. Okay, we can even simplify this even further, but let's do this. And I will go down to the instructions here. So basically, this is the entire, or this is the main program here. Okay, we have like a setup. This is like a setup script, basically, or script, but setup, you know, instructions. And then here's the real program starting here. And so this part, so you can see the line number here. 9, which corresponds to this 9 over here, 9 here, okay, and then 11 is the string here. So basically we're compiling this string because it has an interpolation, so it's stored on the stack. Now we could, you know, optimize this because this is read only, so we could like evaluate this in compile time technically, but I don't have that optimization, so this is stored on the heap right now. So that's why we have, first we have this ref, which is basically a fancy push to the stack. And have we alloc 3, which is allocating 3 values on the heap. All right, so basically this is setting, this is like constructing the string, this string here. This is constructing the string, okay? And then what we have is we have what we have is we have this part, ref identifier, yeah. So then x is, because the result of this expression is something stored on the stack, or it's not actually stored on the stack, it's stored on the heap, but it's like we're popping here, which sets the R register to whatever was on the stack, and what was on the stack was the pointer to the string. Okay, so after this pop, we have in the R register, we have the pointer to the string. And then we want to, because we then see that, okay, we have the result is in R, the R register, but the problem is that the registers are like volatile. So anything you do can basically, like in compilation land, anything that, like R is not guaranteed to stay the same. R is like reused for other purposes. So we want to save that. And so we push another thing on the stack and we set that to R. So we basically create a space on the stack that is then, the stack is then, you know, it's like, it's sort of com time known, a pointer that is like relative com time known, and it's so then it becomes like shareable here, so we can actually share this ref around without being worried about this being overwritten, or, you know, it's volatile. So now we have a pointer, basically a stable pointer to this x. But so okay, so we can use it, but the problem is that it's only stable, or it's only accessible in the same thread, and that's the issue here, because this expression is spawning another thread to call echo. That's just how it works because of reasons, but because of pipelines and streaming the standard out and all that. So we need to have a fork here, and you know, it's not only this expression, it could be, you know, surrounded in a block, it could be called from a function, whatever. The point is that this x now is referenced from within another thread, and since the threads don't share the stack, they have each thread have their own stack, and that means that when we pass this x down here, it's not really referring to it can't refer to the same thing that it's referring to here, since this refers to the stack of the outer thread, but this has to refer to something else. And the question is, how do we wire it up so that we can share this x to this inner thread, you could say, or this this other thread that's happening down here. That is the problem here. And So because after this has been set, we now have a stable pointer to X within this thread, but when we fork it down here, this thread does not have a stable pointer anymore. This does not have. Why X could be accessed by another thread, by other thread. So yeah, so this expression here happens in a separate thread in the virtual machine. In like a it's not an actual real thread, it's like a virtual thread. So we're talking about a virtual machine here, but the threads, what they share is the read-only data, and they also share the heap. That's shared memory. But then the stack is not shared. Yeah, the stack is not shared. Now, I was thinking like one way to maybe solve it is to make a different kind of pointer that would be able to reach into other threads, stacks, and refer to like a specific thread's stack, and grab the memory from there. But that becomes cumbersome because then we need a different kind of type of value for that. Another idea is that we somehow like make this available, like for example on the heap, or we like in some capacity could push it on the stack here. But the problem there is like you could be deep into the compilation of this. Like this doesn't have to be here. It could be, you know, deep in like here, and it needs to be available. And now we know it should be available, right? So so what should happen is that this thread now kind of requests access to this X, and somehow we provide it, and then it can use it. So you'll have to define a shared state that contains all the stuff, or another way, but you can't use stack memory if your runtime will use multi-threading. So I'm using, yeah, so stack is perfectly fine to be used like within a thread and within like these compilation units where you have control over what is in a thread and what is not in a separate thread. There you can use stack, you know, with because stack is very useful because it's as I said, it's like a stable kind of pointer where you can store things basically. So and since, you know, eventually you would run out of registers, for example, if you want to use those, although registers are also thread local, so you can't share it by register either. You have to share it by somehow, maybe like in the transition of like when we fork, we can actually provide more values into the stack, like because as you can see here, this fork actually we provide these things kind of like an argument to a function, like the fork provides these things. So S stands for stack, which is the, and 0 is you know, the first element on the stack. So what this is doing is basically providing the first element of stack, the second element, and the third element on the stack, and those three are put on the stack of this forked thread. And that's basically the arguments to the fork. However, that is like hard-coded right now. This, and the reason why we have the three things is because we have standard in, standard out, standard er. Thus, that's the context that we're pushing into the fork. But we could also, you know, we could also provide more things. Like we could, of course, if we see that, okay, well, X is needed. Okay, well, we could push X for, because what this is kind of used here for is that this refers to the outer threads stack, but then it's pushed into the inner threads stack. Yeah, it's copying. So we could also copy the pointer here into the inner thread stack. So we could extend fork to have a bunch of things you could push in there. The problem, though, is that if you're using the stack, like in this thread, you're using the stack, all those stack, like for them to be kind of, you know, for us to be able to know where in the stack we're talking about, the stack pointers need to be like relatively stable to the stack frame. The stack frame is basically when we fork here, we create a new stack frame. Set 4. You don't see it here, but basically when you fork, you get a new stack frame because this is a new thread. And so here, stack frame is actually pointing to 0. Actually, it's pointing to 3 because of the 3 things put on the stack. The trouble is, like, and then you can see already here, we're pushing something on the stack here. And this, well, it doesn't say pushes, it says ref, but ref essentially does a push with a label. So for us to be able to know what this ref is pointing to, we are actually saying that, okay, well, this is pointing to stack frame plus 3. So we have the context, and this is actually a register. Stack frame plus 3. But later we'll encounter X, and that will say, hey, we need this now in the stack. So then we go back and modify the fork to say that, okay, well, let's push another thing in here. But the problem is that that changes the base of this thing to be 4 things on the stack instead of 3. So then we need to kind of modify this ref to not point to stack frame plus 3, but stack frame plus 4. I mean, we could do that. We could also create a new, I mean, I guess we could create a new stack frame though, maybe. The problem with the refs are that they are always relative to the current stack frame. So it's like, how do we even refer to X here from like another stack frame? We can't. We have to be in the stack frame. I think. If you use a stack pointer from another thread, isn't memory violation? Yeah, but that's what I'm saying. Like, we're copying. Like, when we're forking here, we're copying these values from the outer thread, and then this instruction will actually push these things into the new thread. So we're basically copying those things to the new thread. So that's how they are transferred. They are transferred here in this fork instruction. But then there's no way of, like, once you're in the thread, there's no way of referring to the other thread's stack. You're always referring to your own stack. Maybe define an intermediate table like proxy table for values and get from the IT if the value is interpolated. Yeah, so basically any kind of like, even if you have like a block here, and we say that, you know, const y equals x, even this requires x to be transferred to this, because this is run in a separate thread as well. So this needs to be transferred, or x needs to be transferred to this block before we can refer to it here. But this is like more easy, I guess, because this is the first statement that happens. This is like happening way in here, which is troublesome, because it's not as easy as saying, okay, well, we need x, so let's just push it. Well, we don't know if we need x until we're in the compilation here. I mean, there might be some other context we could use maybe to fix this, but instead of passing n arguments to the new fork process, a shared table sounds a better solution, but should use heap. Do you mean like a symbol table, like a table that like a shared stack? Because the contents need to be, it needs to be runtime known, of course. It can't be comp time known. It needs to be, well, it needs to be sort of semi-stable, if like it needs to be like semi-comp time known. So x here is like the pointer to x is sort of comp time known. It's relative to the current stack frame that is known in comp time. We can know the relative, like +3 here is comp time known, but stack frame is not comp time known, but +3 is comp time known. So if we're able to detect if a variable's reference in compile time, we can push to a shared table between threads. I'm just thinking, like, okay, because we already have shared memory through the heap. So what you could do is allocate some stuff on the heap and then push it there, and then have that pointer being shared. The problem is then sharing that pointer becomes the problem. It's kind of like moving the goalpost a little bit. I mean, what we maybe could do is add a register to the thread that will point to some shared memory that is like those, that is the kind of works like a stack, but it's put in shared memory. And then when you call the thread, it's like when you fork the thread, you set that register to whatever memory you pushed that to. So basically here we could say that, okay, well, x is on the stack now, okay, so let's like allocate one thing on the stack, and it's gonna be, you know, it's where it's put on R, so it's basically we're setting R to X here. We're dereferencing. Okay, so that will put this on there, and that will keep track. Then we have a special kind of location for X, which is this shared memory plus 0, basically. So the result here is going to be like, I'm not sure what to call it, but transferred memory or something. And then the and then plus 0 for the index, or 0. So basically, whoops, let's do like T0. Okay. T0 for transferred memory 0. Okay, so then when we fork here, this is then forked to set 4. You know, S0, S1, S2. And then we provide a fourth argument, and only a fourth more argument, which will be where is the shared memory. And that is going to be the shared memory is now in R, actually. So that's just R there. Let's say we probably put it on the stack and use that. But basically now in this case it's R. So that would be the pointer to where the shared memory is on the heap. And then when inside the fork, so this will be set 4. In the fork then, to be able to refer to the shared memory, we have another, what's going to happen is that the threads register for the shared memory set to whatever this was allocated to. So this will be, so I'm going to say like shared memory register, or transferred memory register, let's say. So when we refer to this pointer to X, we can say TM, you know, TM plus 0 or whatever. This refers to X now. So that way we don't have to mess with the stack. We're using the heap to share this in here. And yeah, that could work. Stoneware share, not copy values, having duplicated the same value in multiple thread stack. Yeah, the things that we're kind of duplicating is the pointers to the things. We're not duplicating like the contents here. Like the contents of this is stored in the read-only memory. And then X is like a pointer that points to this kind of the content of this. And then what we store on the heap here is the pointer to this string as well. Okay, and then the reference to X is actually going to be like a relative pointer that is T0, and that will kind of equate to the TM register plus 0. Now this might be way more complex than it needs to be, but it's like a I don't know. It's sort of like a solution, I guess, to this. What if you end deep context using S? Yeah. So that's the next issue. Is that what if this is surrounded by a block, which is also in its own thread? So now we have two nest. It's nested twice now. Well, we have to recognize then that, well, first of all, we have to recognize that we need to thread X into this one. So how do we do that? Well, we can see that, okay, whenever we encounter this identifier and we look it up and we see that, okay, it's from an outer context, then we need to kind of modify our current context to request that. And now we see that, okay, well, now we need this thing. So this will get added to, yeah, somehow. I'm not even sure how these instructions are going to get added here, but but yeah, somehow this will get added, and here, and then this is the easy part here, but then it's like, okay, well, we're going through another context here, which is this one, and this doesn't have X either. So we also need to request X from this scope. But then we get out here, and here's the source. Okay, so now we can kind of thread it through, but that's, yeah, I have to figure out, like, okay, once we encounter this, how do we modify this thing to actually like create the setup to do it? It's like this, the compilation of this needs to be deferred until we have compiled the whole thing to know, okay, well, we need this to wire it up as well, and then we add that in as well. Yeah. Yeah, I'm pretty sure, like, what we could do is, like, because right now we already have like a scope stack, which are which is these ones. Why isn't it going to that? Okay, well, we have this this thing here. What's happening? It's not working. I can't go to definition. Okay, but anyway, we have this scope stack here, and as you can see here, it has a bunch of frames. Now each frame here is like a scope, you could say. So this is the scope stack here. So whenever we have an inner scope, we have to push a new frame, right? And so if we are in an inner frame and we request a thing from outside, we have to transfer that into this scope. So as long as the scopes are in sync with the compilation, like we have then we can see that, okay, well, once we look it up here, we look up a name in our current scope, which should be somewhere here. So how this works is basically we start at the innermost scope that we have right now, and we look for the name, and if it's found in that scope, we can just use it locally. But if it's in an outer scope, we have to go back to get the bindings of an outer scope, and then we know that, okay, well, it wasn't found in the current scope, so it had to be in an outer scope, and then somehow we have to kind of connect it from there. So yeah, This is way messier than I was ever expecting, actually. But yeah, I knew it wasn't gonna be easy, I guess. But it's, yeah, this is. I mean, part of the reason is you have to think about kind of the assembly like language, like what you have to work with, and also what you choose to have to work with when compiling this. I mean, there might be some clever solution to this that I'm not seeing. Of course, there probably is a lot of those. But yeah, I'm trying to figure it out and see. Yo, cool guy, what's up? What's up? Welcome back. So yeah. I mean, there's also the idea of like statically analyzing beforehand to know where this is going to get used, how to hook it up, so that we know beforehand, so we don't have to do the whole, oh, now we encounter you, and you are required here, and then you're required here. So I mean, you could do that, maybe, I don't know. Maybe it's better to statically analyze and figure it out beforehand. Because then we probably don't need to put. Then we can just transfer things by stack instead of by the heap, and a new register. We could change fork to be like a variadic function basically, and then add however many things on the stack that we need to transfer. How to be faster. In Office they demand faster. I mean, yeah, I don't know. It's either a question how to be faster or a question of understanding estimation and requirements and how long things actually take, and communication between. I mean, usually you have do you have okay, it's up to the process, I guess. Like, how do you have like a scrum master, or because if you have some sort of setup like that, you have like a different roles, like a product owner, some kind of process person, and then you have the developer, and then usually you would ask a developer, how long is this gonna take? But I know there's of course places that doesn't work like that. I don't know. Every place is different, so it's I don't know how it works. How do you cover stuff before deadline? We don't really have. I mean, yeah, that's the thing. Like, not all places have deadlines. Like, I've never really worked with deadlines. We don't really work with deadlines. What you do is you kind of estimate. You get like some requirements, and then you estimate, okay, this is gonna take, I don't know. Well, there's a whole bunch of different ways to estimate as well. But let's say you're saying like, okay, well, this takes like maybe 3 to 5 weeks or something like that, and then they ask within 2 hours. Entire bank reconciliation function to parse bank statements. What? So they're asking you for a specific function in 2 hours. That's... I've never heard of that. To parse bank statements. I mean, you could use AI. I guess that will maybe go faster to help you out there. But why is it... Why is like, yeah, in 2 hours? Do you go bankrupt if you don't get it in 2 hours? That's weird. That's weird, man. I'm going to become AI stack developer now, 100 times faster. I mean, it's not a. I mean, yeah, it's. I think if you utilize AI in a good way, then it could be a really good companion, like a really. All right, yeah, I think I need to sleep on this a little bit. This problem is this is probably one of the hardest things that I had to think about in this project, actually, and it sort of came out of left field here. Like, I thought the virtual threads was gonna be, but I mean, I guess this is part of it. This is part of it. Interesting. I might have to read up on it. I mean, basically, it's also how, not even threads, but basic scopes, like how to share, and also closures, like how to share in assembly, basically. You know, the variables into function closures and inner scopes. So yeah, I think I will have to kind of do some research in Compiler Explorer and see, maybe, to see how it's done there, because I mean, it doesn't really have the same like thread issue, but it does have like scopes, inner scopes. Unless like, no, I'm pretty sure it has like scopes. Like if you have an if statement, it's a different scope than. Also, I think you can have like blocks as well. Yeah, we'll see. Yeah, they become angry if I don't do it in 2 hours. I mean, have you, or is it, or is your clock ticking right now? What kind of skills do they prefer in your job role? Well, right now I'm mostly working on front end. So it's like TypeScript, React. Being able to take, like, look at design and create components for that. Connect to backend. Also a little bit of, you know, interpreting requirements. It all depends on what roles other people take. Like sometimes you end up with leadership that doesn't actually do much work, and then you have to do like a whole bunch of stuff yourself. Other times you do end up with separate people with separate roles, like a real product owner that actually does the job. And but yeah, the kind of skills yeah, just, you know, being able to read and write code, basically. But prompting is the new thing. Like prompting is the thing that we're currently experimenting with and trying to figure out. So that is not even like, you know, it's not even required, you know, right now. But it might be in the future. It's not really stress free, but I mean, okay, relative to what it sounds like that you have right now, it's kind of stress free, yes. But we actually do have a deadline right now, but it's like it's on longer time span than 2 hours. But did you solve the issue, or do you need help with that? I think, I mean, yeah, Blue, it depends on your experience level. Like if you're more experienced, you have an easier time getting a job. And it also goes like up and down a little bit, like, and I mean, of course, then it also depends on, you know, where you live and all that. So it's different between regions. But I would say the overall impression that I have is like right now for juniors it's pretty tough, which is bad because I mean, if people don't hire juniors, there's not going to be people later experienced to take over. If you're only gonna hire like, you know, experienced people. It's not even a year. I mean, to be fair, it sounds like you're working in like a hellish environment. Yeah, breaking into the industry. Yeah, I've heard that it's more difficult now than it was before. Like when I started, it was like I just applied everywhere. I didn't even take a software engineering job. My first job out of school was not even software engineering. It was like a kind of adjacent, but it wasn't really engineering in that sense. But then I was lucky and got one. And then you had just the foot in the door. I mean, you can do, yeah, you can do on the side. Why not? Get a little bit of extra experience and, you know, extra jobs, yeah. And if you learn to use AI properly, maybe you can like accelerate that as well. Do arts and stuff. I mean, I think that's also difficult. I've heard to like earn money on. I don't know. And I was thinking like painting and stuff like that. To get internship, you have to be in the top tier. Here they will reject. What? Okay, that sounds like a scam. You don't search for internship if you're top tier. Or are you talking about top tier of the juniors? Because that makes more sense. Which I can understand. I methat's just a consequence of how. I guess there's many people who wanted to get in. You can also look for like international. You can try to look for remote work. I'm starting to lose it. All right. Yeah. I have to go and eat now. I have to sleep on this issue. I'm just gonna type this down here. Compiler. So transferring, or well, the problem is getting bindings to be shared between threads and scopes, basically. Yeah, this requires some sleep on that. Ramen. Not really. I don't know. I've never had a ramen that like takes my breath away. So I'm not really that big of a fan. But what I have is something called korv stroganoff. Which is like kind of like what you call it? I mean, it's sauce with you know, a Swedish kind of sausage called falukorv and tomato, basically tomato-based sauce with onions and stuff and sausage and rice. But it's good. I'm so confused. I serve the XSDs and I can see the data on them, but I still get error connecting game service. Okay, but did you change the thing? These things, did you change this? Or not this, but did you change it to this? Okay, you change. Okay. I mean, like, do you have the code where, like, do you have all the code on the client? I mean, I guess you have because you're disassembling it, but right. But then, I mean, technically, you could find a place where it's trying to read this. You can even look at, you can search for the errors, the error that you get, and try to see if, like, where this is happening. Yeah, on Twitch. Yeah, it's actually not Java. It's Action Script. Yeah, I think you would have to kind of look at the code a little bit there. I wonder if I'm just properly hosting the game server itself. Yeah, but I would look at where the error is happening in the client code and try to work my way backward from there to see why is the error happening, and then go from there. Because otherwise, it's too much of a guessing game. Like, you could spend forever trying to guess what the issue is. I think your best bet is to try to find a part in the code where this is happening, and just search for the error message. Maybe you'll see something in the search for it in the code. Do you want to share the client code, or is that maybe that's maybe breaking something? I don't know, breaking some. JXDS to run it and see the debug log. Wait, so you can get a debug log? I mean, I think I have Twitch chat. Oops, that's not correct. Okay. One second here. Let's see if I can fix this. Well, what the hell was it called? Okay, I think. Whatever. I'll try to fix this. I'll try to fix this later. I do have like the Twitch. I can show the Twitch chat. Now I'm using a Zig built project. I forgot what it's called now. But I did make, like, you know, in NeoVim, I made a little script that shows it like on in a floating window. It's public. I can send it to companies. Different. Okay, yeah, sure. But I think I'm gonna have to do that tomorrow. maybe. Let's see. How does it look tomorrow? Yeah. Yeah, tomorrow looks good. Yeah. I mean, my tip is to look in the code, as I said. Like, search for the error message. Maybe you'll find it in the code, and then work your way backwards from there to see if you can find why it errored. And yeah. All right. But that's gonna be it for this time. So yeah, we have yeah, this thing is like a beast to me right now. It's, yeah, I need to fix this. But yeah, thank you very much for joining me here. I think I'll send you off to somewhere. Let's see, on Twitch we can raid. Let's see. That looks cool. Alright, there you go. But yeah, thank you very much for joining me, and hope you have a nice day. I'll see you later.